Before I do an example using inverse proportion, let's just talk about what is the formula. When y and x are inversely proportional, y is k over x. So that's the idea. So notice here, just think of fractions. 1 over 10, 1 over 100, 1 over, well, maybe I should write it here so it shows up on the video. So think of fractions. When the denominator gets bigger, the overall value of the fraction gets smaller. Yeah? So the inverse proportional y and x, that means when x gets bigger, y gets smaller. Or vice versa, when x gets smaller, y gets bigger. What's an example of everyday type of situation that behaves like that? Think of a balloon, and you have pressure. The pressure is inversely proportional with the volume. That is, as the volume gets smaller, the pressure gets bigger. Think of a balloon. Now, if you take the balloon, now I know when you squeeze it, the balloon squirts out your sides of your finger, but if you could take that and squeeze it down, the pressure inside gets bigger, yeah? So when the volume gets smaller, the pressure gets bigger. Likewise, if you take a balloon and if you make it bigger, the volume inside, when the volume inside gets bigger, the pressure inside gets smaller. That's an actual everyday example of inverse proportion. So now let's do an example. Y is inversely proportional with x. That means we use that equation, y equals k over x. If y is 8, when x is 2, well, the first step is to find k in these variation problems. Multiply both sides by 2, and we get k is 16. And we plug that in there. So the formula in this situation, k is 16. So this is our formula. And now we do the rest. Find y when x is 4. Well, when x is 4, 16 over 4 is 4. So there's the answer.